Hello, good day. Nagbabalik na naman tayo para sa ating integration course for machine design. So, ano bang pag-uusapan natin ngayon? Let's go with three topics para sa machine design 1. Okay? So, let's go with thin-walled cylinders and spheres, spring, keys and coupling, bolts and screws. Yun ang ating pag-uusapan pagdating ng ating machine design. So, you have to take note of all the things na gagawin natin at sasabihin ko sa inyo at tuturo ko sa inyo. Ngayon, let's first talk about thin-walled and thick-walled cylinders. So, ako, what I did is to make it short para madali nyo tandaan. Okay? And the notes for this will be available after nung video. Okay. I have made a PDF copy nung summarized formula ng ating buong topic. And now, ano ba yung pinakamagandang gamitin natin na formula pagdating sa thin-walled and thick-walled cylinders? Now, since pressure vessels sila, I have decided na paikliin natin. Okay? Now, meron tayong 8 problems para matackle out yung sample problems and then ito yung discussion niya. Okay? Now, for your thin-walled and thick-walled cylinders, paano mo ba ma-check if that is a thin-walled or thick-walled cylinder? Ganito yan, mga kaibigan. For pressure vessels, in order for you to check if it is thick-walled or thin-walled, you just have to get the ratio between the thickness of your walls and then the diameter of your pressure vessel. Now, if your thickness, when you divide it with your diameter, the diameter, or the given diameter, if that is less than 0.07, then that is thin wall. Pero if that is greater than ED is greater than 0.07, that is thick-walled na. Thick-walled cylinder. Kailangan ganito yung kanyang condition. Okay. Now, meron tayong dalawang uri ng thick-walled and thin-walled pressure vessels. Meron tayong cylindrical at meron tayong spherical. Pinagkaiba lang nila is the surface area and the volume. Okay? Wala namang pinagkaiba sa formula. Now, ang kailangan mo na lang tandaan, what is tangential and what is longitudinal. Pagdating ng cylinder mo, dalawang stress ang pwede mong makuha. It is the tangential and the longitudinal. Ngayon, ang pag-uusapan dyan, meron sinasabi, hoop stress, normal stress, mga ganun terms. Pero ako hindi ko na sila nilista. All you have to remember is that yung ating tangential stress is always the maximum stress. Kasi yung area that is in effect is smaller than the longitudinal. Okay. So, tandaan mo, that is the maximum stress if that is tangential, and longitudinal, that is the minimum stress. Ngayon, kapag nagde-design ka ng cylinders or pressure vessels, ang lagi mo i-consider is the maximum stress. Why maximum stress? Kasi, pag nag-design ka, lagi ka dapat may pasobra. Okay? Hindi ka magde-design ng isang bagay na that will fail into minimal or less usage. Okay? Now, what are the formula involved dito sa ating cylinder? Pagdating ng iyong tangential stress, that is PD, that is inside pressure, okay? Internal or inside pressure, inside diameter or internal diameter divided by 2TE. What is T? That is the thickness of the plate that is used to make your pressure vessel, and E is the joint efficiency. Okay? Siyempre, wini-welding yan. Kailangan mo i-measure. But there are times na hindi binibigay yung iyong efficiency. What will you do? As is, ang efficiency mo, pag hindi ibinigay, that is 100%. Okay? If not specified in the problem, use 100%. Now, for SL. SL. Ano ba SL? Longitudinal stress. That is inside pressure, internal pressure, multiplied by internal diameter or inside diameter, divided by 4TE. 4TE. Okay? Yun lang naman ang kailangan yung tatandaan. And for spherical, wala naman yung longitudinal, wala rin yung tangential. Lahat yan pare-pareho. Iisa lang ang formula na kailangan mong i-memorize. That is PD over 40. Laging inside pressure. Okay? Don't you take up na yung mga outside pressures. Okay? Since the outside pressure naman is mostly atmospheric. Okay? So, ang pressure na lang, nasa loob. Yun yung kukunan mo ng pressure. That is the pressure applied. Okay? Sa loob. Now, when you are given a bursting problem, mamaya ma-encounter natin. Bibigay sa'yo yung pressure vessel mo and then bibigyan ka ng bursting pressure. Or hahanapin yung bursting pressure. Bibigay sa'yo yung tensile stress ng iyong material and then all you have to do is yung design pressure or stress, design stress, the internal pressure, equate mo dun sa ratio ng tensile stress mo and then the bursting pressure. Kapag binigay ka ng bursting problem, later on, ma-encounter natin siya. Now, we'll talk about, ganun lang kaikli yun yung pressure vessel mo kapag thin wall. And pag thick walled na, it is either equal or greater than 0.07. Now, ang daming types ng stress dyan. Ano bang kailangan mo lang i-memorize? Sir, ganito lang yan. Tatatlo lang ang kailangan mo i-memorize. Okay? Siyempre, kailangan mo na rin i-consider yung outside pressure and then the outside sizing. Outside the diameter, yung outside radius niya. Now, for axial stress, lagi mong tatandaan, ang axial stress is SA, piri, poro, overori. Piri, poro, overori. Piri, poro, overori. Okay? Ulitin natin. Axial, piri, poro, overori. Piri, poro, rori. Okay? Lagi may squared sila sa lahat. Piri, poro, rori. Hindi mo makakalimutan yan. Okay? Mauuna parati si piri kasi lagi mas malaki yung inside pressure kaysa sa outside pressure. Now, for radial stress, depende kung anong gagamitin mo. Okay? Bakit? Sir, kasi kapag tinanong na outside, okay, siyempre, ang gagamitin mong multiplier doon sa kanila is the outside. Okay? Yun ang gagamitin mong multiplier. Ngayon, may napansin kayo? Let us check tignan nyo. Kaya ako pinagtabi-tabi yan, lahat ito, pare-parehas, magkakamukha. Di ba? Magkakamukha. Magkakamukha sila. Ito, si Piriporo. Piriporo Rory. May mapapansin kayo dyan, kung mapapansin nyo, pag radial stress, may SA pa rin siya. Ayun, no? Si SA pa rin to. So, SRX, pag radial, that is SA minus Piporori. Piporori. P minus O. Rho squared, re squared over Rory. Nakasquare pa rin. Laging nakasquare yung Rory sa baba. Okay? Sa taas na nagkakaiba. Now, may multiplier tayo dyan. Depende yung multiplier mo. Okay? Kung ang tinatanong is the outside stress or the inside stress. Multiply mo siya nung Rx. Ginawa kong Rx yan it is either RI or RO. Depende sa problem yan. Mamaya makikita natin. Okay? Ganon din naman kapag tangential. Makikita nyo, ano ang maximum stress sa kanila? Siyempre, ang maximum stress mo is tangential stress. Bakit, sir? Kasi nagdagdag ka pa. Idinagdag mo yung isa pang stress dun sa SA mo. So, that is the total stress. Tangential stress. Okay, tandaan natin, si SA, piripororori. Okay? Piri. Nakasquare parate ang sizes or the radius. Laging nakasquare yon. Hindi pwedeng hindi siya nakasquare, ha? Tandaan nyo, ang laging nakasquare is the radius. Okay? Yung pressure, never mong i-square yan. Okay? Ngayon naman, pag radial, minus yan. Tandaan ko sa radial, pipo, rori, over rori. Okay? Tangential, pipo, rori, over rori. Parehong square dyan. Multiply ko na lang yung labas nila if either that is outside or inside, malalaman mo na lang yun sa problem. Okay? Okay ba? Ganun tayo. Now, introduce natin yung Lam's equation. When you want to know the thickness of the plate, okay, given yung stresses, all you have to do is to use this equation. Okay? Yung tensile stress minus tensile stress outside equal yan sa inside pressure minus outside pressure. They are rational. Okay? So that is for your thin-walled and thick-walled cylinders. Now, let's go to problem number 1. Okay? Para mas madali natin siya maintindihan, i-apply natin siya. Okay? So, number 1, a thin-walled kagad. Hindi mo na kagad i-check kung that is thick-walled or thin-walled kasi binigay na kagad. Thin-walled cylinder is 15 inches in diameter. Okay? So, 15 inches in diameter. As is DI kagad yun. 15 inches. Okay. The internal fluid pressure in the cylinder, internal fluid pressure, the internal pressure, the PI, 150 PSI. PI is 100 PSI, pounds per inch squared. Ganito ko mag-solve para yung unit cancellation nyo is dire-diretso na lang. And, what are the other given? The thickness is 0.125 inches yan. Find the induced stress in the cylinder. Siyempre, induced stress is the induced stress. Ang lagi mo dyan sasabihin, induced stress, kapag hindi binigay ko maximum or minimum, kapag induced stress, that is always maximum. Okay? Yun ang gagawin mo. Hindi binigay sa problem if that is maximum. Okay? Check mo dun sa given kung nandun ba yung sagot. Kaya hindi mo alam eh. Pero lagi mong unang itatry will be the maximum pressure. Now, that is the maximum. ST max. Okay? That is given by the formula PI, PD. PD to TE. PD to T. Okay? PD to T. So, ST is equal to PI, that is 150 pound per inch squared. You multiply it with 15 over 2 times 0.125 inch. Yung E, tignan natin, may binigay pa siya. So, wala siyang binigay as is, that is 100%. So, we multiply that with 1. Okay? So, ST or the maximum stress induced is 150 times 15. So, pound per inch. Maka-cancel yung inch din sa dalawa. 2 times 0.125 times 1. So, the answer will be 9,000 PSI. Madali pa ito. Okay, that is problem number 1. For problem number 2, With a present water interruptions prevailing in Metro Manila, kukulang daw ng tubig. You have been asked to design an upright cylindrical water tank 6 meters in diameter and 6 meters high, vented to be filled completely with water. Now, paano yun? Okay? Hindi natin alam. Gagamitan natin ito ng utak. Okay? Determine the maximum thickness of the tank plate if the stress is limited to 40 MPa. So, you are given stress na 40 MPa. And you are given dimensions okay, ng cylindrical tank. This is your cylindrical tank. Nag-drawing na. Okay? That is your cylindrical tank. That is 6 meters in diameter. 6 meters. Tapos 6 meters high. Now, if that's 6 meters high, anong kulang natin? Now, yung pressure, binigay sa kanya, this is ST, pero hindi natin alam sa internal pressure. Now, base sa inyong hydrostatics, the internal pressure is given by the formula, ano? Siyempre, madidetermine mo si gamma ni water times the height of the water column. Okay? Given yun nun. Now, internal pressure is given by this formula. Okay? Gamma H. That is pressure. Go back to your hydrostatics para matandaan nyo or fluid mechanics. Okay? So, given by this formula, ST is equal to PD2TE. Siyempre, nagdi-design ka. Ayun yung keyword, design. Babasihan mo ng design mo is the maximum induced pressure it will carry. Hindi yung minimum. Okay? 2TE. Equal yan sa, yung P equal to, ayun no? O, di ganyan, HW times TI over 2TE. Wala naman binigay na E. So, gawin natin tong 1. Okay? So, ST, ano ba hinahanap natin? Si T. The thickness, maximum thickness of the plate. So, i-reform natin T. So, gamma ni water, H ni water, Di over 2ST. Wala na si E, that is 1. Okay? Ano bang gamma ni water? Ang gamma ni water is given by this one, 9.81 kilonewton per meter cube. Okay. Yung height ni water, that is 6 meters. Tapos, yung DI, that is 6 meters too. Okay? Divided by 2. Ano ba yung given sa'yo? 40 MPa. Gawin natin siyang KPa. Okay? That is 40,000 KPa. Kilonewton per meter square. Now, cancel natin to. Cancel natin. Cancel natin si meter. Okay? Para maging meter na lang ang lalabas. So, the thickness will be equal to. Okay? Gagawin natin to. Ang thickness naman in millimeter. O di, mamaya natin i-multiply. So, let us solve. Ang lalabas yan in meter. 9.81 times 6 times 6,000 na agad. 6,000 millimeter. Kinonvert ko na yung meter to millimeter. Okay? Ganito. 1,000 mm per meter. Okay, ganun na yun. 6,000 over 2 times 40,000. Kaya lang, ang E niya or the efficiency of the joint is 100%. Wala kasing binigay. So that is equal to 4.4145. 4.4145 millimeter. Diba? Ang simple lang. Okay. Let's go with number 3. Okay? Ito na yun, yung bursting. Okay? So, a steel cylindrical air receiver with 5 feet diameter and a pressure load of 180 psi. Okay, tanggalin natin tong iba dito. Okay? Para hindi natin alam. Design stress. Binigyan ka ng design stress. SD. Tapos merong ang load na 180 PSI. That is PI. Sa loob yan. Okay? The pressure vessel is to be provided with 1.2 inches diameter drain valve installed at the bottom of the vessel and the safety pressure relief valve. Okay? Yung safety pressure relief valve, ibig sabihin kapag lalapit na siya sa critical pressure, magbubukas yung relief valve para bawasan yung pressure ng iyong cylinder. Kung may nakikita kayo sa mga air receiver, sino meron mga compressor sa inyo, yung nandun sa puwitan na parang nozzle, parang pag pinindot mo, sisingaw. Pasingawan ang tawag nila. Pressure relief valve. O-open yan at a certain pressure, parang thermostat at a certain temperature umo-open siya. Eh ito naman, it is pressure activated. At certain pressures, magbubukas siya in order to regulate the pressure that is carried by your cylinder. In order para hindi sumabog. Okay? Installed either at the top or topmost or the bottommost side with pop-out rating. Ito yung burst pressure, 200 PSI. Assume 100% weld joint efficiency, top welding tensile strength is 6,500 PSI. Ilang pressure binigay sa inyo dyan? Ito, pop-out rating. Rating lang yan, pero hindi yan yung bursting. Ano bang hinahanap? Bursting pressure. Now, we say this is thin cylinder. Always, kapag mahirap i-compute ang bursting kapag thick-walled cylinder, ang haba ng formula. Ang ganitong problem, pag na-encounter nyo, all you have to do, get the ratios between them. Bakit? Kahit i-simplify ko pa yan, ang pressure pa rin yan is maximum. Yes or no? Yes. Ang design, ang tensile niya is maximum, the PD over 2T. PD over 2T. Okay? PD over 2T, PD over 2T. Pero ang kalalabasan dyan, okay, we say equal yung kanilang panggagalingan na sizes. So, we cancel out the size. Now, meron tayong shortcut na bibigyan ka ng design stress. I-divide mo ng pressure of internal. I-ratio mo, equal mo, dun sa tensile na ibinigay, divided by yung bursting. Makukuha mo yung si bursting. Now, binigyan ka ng SD. Ano ba yung SD? Si SD is 9,500 PSI. And then you are given internal pressure na 180 PSI. And you are given yung tensile. Ano ba yung tensile na binigay sa'yo dyan? Pagkakatanda ko, 65,000 PSI. And then, bursting. Hinahanap. Now, cross-multiply na natin yung bursting natin. The bursting pressure is 65,000 PSI multiplied by 180 divided by 9,500. Now, what will be your bursting pressure? Tingnan natin. 65,000 times 180 divided by 9,500. So, the bursting pressure will be 1231. 1231 point 1231.59. Yan yung pressure na kung saan puputok yung mga pressure vessel. Okay? So, for number 4, a compression spring is used at a junction of a conical head shell. Compression ring. Okay? Determine the required area of the compression ring. If the pressure is 50 psi and the stress is 13,700 psi. Assume efficiency of the joint is 80%. Okay? Now, given dito, yung, wala palang given dito. Tandaan mo, ang iyong cylinder, may thickness yan. Tama ba? Ano bang formula ng thickness? Recall natin yung ating shafting paghalo. Tama ba na si D equal yan sa maliit na d plus 2t? Yes, ganyan yan. In order for you to get d, i-deform mo yan. D minus d over 2. Okay. Now, ano ba yung area na hinahanap niya? Required area of compression ring. Yung compression ring mo, ayan yun. Parang washer. Okay. Meron kang outside diameter mula gitna. Meron kang inside diameter. D, ito yung D na maliit. Okay, the area, okay, area of your compression ring is equal to pi over 4 d squared minus d squared. Yan. Yan yung ating area. Kaya lang saan natin makukuha ito si D? Okay? Itong D na maliit. Saka yung D na malaki. Okay? Wala ka dyan binigay. Okay? Pero binigyan tayo ng ST. That is 13,750 psi. Equal yan sa maximum to. Okay? P D over 2T E. Okay? May T tayo, may D tayo. Internal diameter to. Okay? So, maliit to. Maliit na D. Okay? Now, we will change this one into smaller D. Yan. Pwede na tayo makasolve na isa. Okay. So, 13,750 equal to P. That is 50 psi times D all over 2 times yung formula mo ng T. That is P minus T over 2 times 0.8. So, cancel. Okay, simplify ko. 0.8, 13,750 times 0.8. That is 11,000. 11,000 equal to 50 times over DD. Minus D. Pwede ko bang i-divide ko na ng 50, 11,000? Divide ko na ng 50 para mas simplify na. And that is 220. 220, multiply natin ng both sides. 220 equal to D over D minus D. Ngayon, ganito ang gagawin natin, mga kaibigan. Okay? The best way is to cross multiply. So, 220 D minus 220 D equal to D. Pagsamahin natin yung magkakaparehas, samahin natin yung magkakaparehas. That is 220D equal to 220 plus 1 D. Divide natin both sides by 220. Okay? D is equal to, huwag muna kayong mag-around. Okay? 221 divided by 220. The answer will be 1.1.004545545. Malit na dito. pwede natin siyang ipasok dun sa value. Ni d squared. Okay? The area will be 5 over 4 times square natin siya 1.004545545 d squared minus d squared. Now, the area will be, square natin to, minus 1 times pi divided by 4. The answer will be, yun yung answer. 0. Hindi natanggal si d squared, sir. Oo, ganun talaga yun. 0.07156 d squared. Yun yung area na. Okay? You don't have to ask anything. And for part 2, wait a little bit. So we'll take a break. And